In this lectures, we will learn how to find the integral for any trigonometric functions when it is raised to even or odd power. We will discuss some strategies and some notes to help us to find the solution in easy and simple way. Let's start and let's see how we will do that. We have here the integration for the trigonometric function when it is raised to even or odd power. For this subject, we will divide it to three main sections. The first section, the integration for sine to the power n multiply cosine to the power n dx. The second section, the integration for integral tan to the power n multiply sec to the power n dx, and integral cotan to the power n multiply cosec to the power n dx. The last section, it will be using some relationship of a trigonometric function to compare the multiplication to addition or subtraction. So let's start with the first section, how to find the integral for the sine multiply cosine dx when it is raised to the power. We have here odd power and even power. In this lectures, we will discuss the case when we have the odd power for the integral of sine and cosine. To make it easy for you, we will discuss in this lecture only the odd power to see how we will find the solution. So here, in case if we have the odd power, whether we have the odd power alone or if we have the odd power with even power. To solve this integral, we will do the following step. We have only two main steps. The first step, withdraw 1 from the odd power to get the quadratic exponent and then use this relationship. Cosine to the power 2 plus sine to the power 2 equal 1. Second step, by substitution method, we will solve this type of integral. Let's take some practical example to make the pictures clear for us. As we can see here with this example, find the integral of the following function. Integral cosine to the power 3 dx. How we will solve it? As we can see here, it is odd power. So the first step, we will follow the previous step to solve this integral. We withdraw 1 to get the quadratic exponent. So it will be integral cosine square multiply cosine dx. We just withdraw 1 from 3. So it will become cosine to the power 2 multiply cosine dx. Then we will use the equation cosine square plus sine square equal 1. From this equation, you get this equation. Cosine from the quadratic, it will be cosine square equal 1 minus sine square. Then we will substitute this value in the integral. The integral it will become integral cosine to the power 2 multiply cosine x dx. It will be equal integral cosine square. It will be 1 minus sine square multiply cosine dx. This is the first step. Second step, we will use the substitution method to solve this integral. As we learned from the previous lectures, how to use the substitution method. We will take assumption. This will be our assumption. It will be u equals sine. Then we will take the derivation for our assumption. It will be du equal cosine dx. Then we will put the integral in term of u. It will become integral 1 minus what is sine square. It will be u. It will be u to the power 2 du. Cosine x dx. It will be cosine x dx. It will be equal du. So the integral it will become like this. Now the integral become more easy to find the solution. How to find the solution for this type of integral? We just will increase 1 on the exponent and we will divide it to the new exponent. After we find the solution for this integral, the last step, we will substitute the value of u to put the integral in term of x. Finally, we will get the final result of this integral. Let's see the other example. Find the integral of the following function. Integral sine to the power 5 dx. The exponent is odd number. We just follow the previous step and everything will be fine. Withdraw 1 from the odd power to get the quadratic exponent. So 5 withdraw 1, it will be 4. It will become integral sine to the power 4 multiply sine x dx. After that, the integral will become equal integral sine to the power 2 all to the power 2 multiply sine x dx. After that, we will be able to use this formula, cosine square plus sine square equal 1. It will be, we have here sine, then we will get sine. So sine square equal 1 minus cosine square. After that, we will substitute this one, this value, we will put it in the integral. The integral, it will become integral 1 minus cosine square all to the power 2 multiply sine x dx. The second step, we will use the substitution method to solve this integral. We will assume, we will take our assumption, this part, u equal cosine. After taking the derivative for our assumption, we will get du equal minus sine x dx. And after multiply both sides with the negative sign, we will get minus du equal sine x dx. We will get this part. As we learned from our previous lecture to solve the integral by substitution method. We will put the integral in term of u. So integral, it will become integral 1 minus cosine it will be u to the power 2 all to the power 2 sine x dx, it will be minus du. After putting the integral in term of u, we will get this integral. How we will find this integral? By square expand. By square expand, we will get this value. After finding the solution of this integral in term of u, the last step, we will put the result of the integral in term of x by substituting the value of u. And finally, we will get this final result. Let's see this example. Find the integral of the following function. We have integral sine to the power 4 multiply cosine to the power 5 x dx. In this example, we have even power and odd power. In this case also, we will follow the same as the previous example. What we will do, we have here 5, we will take 1, it will be 4. So the integral will become integral sine to the power 4, we will keep it as it is, multiply cosine to the power 4 multiply cosine x dx. We withdraw 1 from 5, we will get 4 equal integral sine to the power 4 multiply cosine 4, it will be cosine 2 all to the power 2, and cosine x dx, we will keep it as it is. In this case, we will be able to use this relationship, cosine square equal 1 minus sine square. Same as the previous step and the previous example. We have cosine here, then we will get the cosine. From our relationship, cosine square plus sine square equal 1, we will get the cosine square. Then we will substitute this value in the integral. We will get this integral sine to the power 4 multiply cosine square, it will be 1 minus sine square all to the power 2 multiply cosine x dx, we will keep it as it is. The second step, we will use the substitution method and we will take this part for our assumption, u equals sine. After taking the derivative for both sides, du equal cosine x dx, this part. We will put the integral in term of u. After making the square expand for this part, after the simplification, we will get this result of this integral. Now the integral in this case become easy to make the integral. We just increase 1 in the exponent and divide it to the new exponent. And we will get the value of this integral in term of u. The last step, we will substitute the value of u to put the integral in term of x. And finally, we will get the final result in this integral. Let's see another example. Find the integral of the following function. We have this integral. All the exponent of this integral are odd exponents. So we will just follow the same step that we learned from the previous example. We have 3 here, we draw 1, it will become 2. After that, sine to the power 2, it will be equal, sine to the power 2 equal 1 minus cosine to the power 2. And we will substitute this value in the integral. After we substitute this value in the integral, we get this result. The second step, we will use the substitution method to find the result of this integral. We will take this part for our assumption. U equal cosine and du equal minus sine x dx. Here we have sine x dx, and we will multiply both sides in the negative sign to get minus du equal sine x dx. Then we will put the integral in term of u, and we will get this result. After open the bracket, we will get this value. After finding the solution in the integral, the last step, we just substitute the value of u to put the integral in term of x. And this is the final result of this integral. This is for today. I hope it is clear, and see you next lecture.